Hi, hi everyone.
No,
I've got the
thank you
t-shirt as well, actually.
Oh, nice. Awesome. That's a great shout out. I hallucinate more than ChatGPT shirt. All right. Well, I'm going to give you the floor and share your slides. Thanks so much.
Cool. Right. I guess everybody can hear me. So I'll talk about Wardley mapping and prompt engineering. So for those who don't know what Wardley mapping is, I'll just quickly whiz through it, but I'll share some links at the end so you can go and do some more research yourself. So it's used for strategic planning tool, for around your business and services. It was created by Simon Wardley, so you can find him on Twitter, and it helps you kind of visualize and understand the structure of your business based on user needs. So a map this is an empty map. It looks like this. So on the left hand side you have the genesis, on the right hand side you have commodities, and basically all technology moves from the left of the map to the right of the map. Some things can take 40 years. So if we think about computing, originally there was research, it was mechanical, and now we see over time, computing has turned into a utility. So it's the Wardley map is based around the user needs, so it's the anchor. So it starts with the needs of the user. You create a value chain, so the links between and the dependencies between the components in your map. And this is the kind of flow of capital. So the flow of capital could be money, it could be other things, it could be trust. And basically everything starts with your user needs and then kind of flows down through that value chain, and you kind of add all the individual components. So in this case, like large language models, cloud chunking, text splitters, and we'll see that in a minute. And basically, you've got that evolution of the map from left to right, from Genesis, custom, product, utility. And the purpose of the map is to help you make decision making, but it's also a good aid for particular markets, looking at kind of industry challenges and changes, and also improving strategic decisions. And it helps with that kind of shared context. So when you talk about your strategy within the organization, it helps you kind of share that and understand it across all your members. So, and the key thing we'll talk about a bit better is about strategic decision making, and it helps kind of build or buy choices. Where should you invest? Where should you focus your thing? It also helps anticipate change. And because the world changes all the time, the map needs to change. You need to keep it iterated and keep it updated. And it gives you a lens to also look at your competitors as well. And we'll do a bit of that. So this is a very big map. It's very complicated. It covers prompt engineering, and we'll kind of just talk through it step by step. Later, you'll get the slides. I'll tweet them anyway, but you can have a look at this map and play with it yourself. And you can also represent the map using the code, so the kind of Wardley mapping code. And this code can also be put into ChatGPT, and ChatGPT understands this map, and it can help you build the map. It can challenge you on the map, and it's a good way of giving the context to ChatGPT, so it understands the links between the components. It understands the components, and then from that you can create an additional maps or support with the maps. And there's a separate tweet thread on that. So getting into prompt engineering. So with this map, we can anticipate change, understand where to invest, understand technical debt or the risk of technical debt, and understand kind of where to build or buy. And also if we map the capital flow, we can understand our kind of cost per transactions within our map. So the capital flow flows in both directions. So it can be your financial investment, the kind of revenue you get from the public using your services, and that kind of return on investment. You can calculate it. So you can calculate the cost between each component and the cost of that one transaction. So, going into your app or whatever and making those queries like all the way down for the LLMs and back. So this, start at the top of the map, we start with a user need. In this case, is a prompt engineer, and we've got various different use cases. So, and I've simplified this version of the map just so it makes it easier to talk through it. But if we look at kind of questions and answers using kind of private data, to do that, you need that conversation history, and you need those kind of prompt engineering techniques. So like change, fine tuning, the kind of tree of thoughts. Now I've named my own value chain prompting. So this is where you put the value chain into the prompt, and it helps ChatGPT understand the context, and it helps you with the kind of map and helping develop strategies. So you look at the kind of flowing down from the techniques. You've got guardrails. So everybody should be looking at guardrails, making sure that their service that they're building, using large language models, meets kind of ethical, your ethical conditions, the ones that you decide to use. You've got the chains. So we talk about chains. They need the kind of agents, and agents allow you to do multiple things, query multiple LLMs, query tools, so you can go out to external data, go to the web, query other services, call APIs, get data back, put that into your LLM model, query it with kind of ChatGPT, etc. And you can also build custom agents, and you probably have to do that if you're using, depending on your data, your private data, and also the agents can access private data. And to support private data, you need the kind of metadata about the data. And then I've got at the bottom of the map there, we've got PETs, which is the privacy enhancing technologies or techniques. And also you need, you should be thinking about data ops and ML ops and also FinOps within your services, because you need to understand the costs and the cost models for your large language models, and especially around the kind of tokens. And we've just seen, OpenAI reduce the cost of this. And you can also see those kind of red lines. So we know that agents are kind of in the kind of product space, and they're going to move into that commodity space over time. And prompt templates, I mean, I guess they're already a commodity now. There's thousands of them out there on the internet. So kind of moving down the stack, we've got pets, we've got data ops, we've got embedding. So if you want to work with private, your own private data, you need a vectors, need embeddings. So there's various different ways of doing embeddings, from OpenAI to Cohere and FastX. And something I put on the left-hand side of the map is using encrypted embeddings, so to protect your private data. To do privacy enhancing technologies, there's two called fully homomorphic encryption, multi-party computation. Fully homomorphic encryption and multi-party computation allow you to encrypt your data and still do analysis on that data while it's still encrypted. So a key element if you want to protect your data when you're using LLMs. You've got like Concrete ML there. They help create encrypted machine learning models that you can still query when they're still encrypted. And that's from a company called Zama. And you've got Cape Privacy that are looking at pets for chats. So they've got a chatbot that protects and encrypts your data in the chat tool, web interface. So you're doing your embeddings. To do embeddings, you need to look at chunking in chunks. To do that, you need a text splitter. There's various different text splitters based on different types of text, from PDFs to plain text to YouTube videos, scripts. There's quite a few. Llama Hub and LangChain, they both offer many different text splitters. And then you kind of go down, you need a vector database to store your vectors. So you've got options like Superbase, Chroma, Pinecone, and I'm sure all of them are doing different talks today at some point over the next couple of days. And pretty much as we go down the stack, you'll probably find at some point, over the next couple of days, you'll find some of them talking about stuff. And then, your vector database, you need those kind of search algorithms. So, like the nearest neighbors, and the Facebook one face. And moving down further, your vector algos and your vector database, that needs kind of cloud to operate. And then you actually eventually get down to the kind of large language models. So we've got OpenAI, but you also got Dolly, Alpaca, Llama. There's new ones now like Orca, and you've got the Falcon one from the UAE, and they both all claim to be excellent and at least as good as ChatGPT. You've also got the Meta Massively multilingual speech from Meta. So that works with 1,100 languages. And they claim it's good as anything that's out there. And also on the map, we've got this kind of black line next to the LLMs, and that represents inertia. So inertia can be and a decelerator to things moving to the right of the map, and open source and an accelerator. So this is why we see open source LLMs, because it accelerates those services moving over to commodities. And we kind of got OpenAI. Now, what we can do, if we look at the large map, we can say, like, people talk about prompt engineering. It's not prompt engineering, it's prompt crafting. It's literally just writing prompts. Yeah. Then we've got the bits down the bottom about our algos, nearest neighbors. That's computer science. We've got the stuff around the large language models. That's data science. Then we've got the stuff, all the kind of infrastructure and all that. That's ML ops. Then we've actually got prompt engineering, which is all the stuff at the top, and it's a much bigger than, it is literally engineering, not writing scripts. This is what OpenAI does. This is what OpenAI does in the public. This is what OpenAI capabilities OpenAI have. If they decide at any point to make any of this available via their APIs, they're going to eat your services you're currently thinking about building for lunch, dinner, supper, and breakfast, because they have a platform. At any moment they can turn APIs onto any part of their infrastructure, and then they will just basically eat whatever you're thinking about building. That's kind of just getting the 10 minutes. So what we can do with Wardley Maps, we can understand user needs, build that value chain, understand the evolution of those components, help with strategic decision making, anticipate change, understand where to invest, understand your technical debt, and decide where to build or buy. There's all the resources, and thank you very much. I'm done. I'll share the links later.
Awesome, thank you. Yeah, and we're also going to get this recorded and share that out as well. So thank you so much for joining us, Mark. We really appreciate it. All right. So long.
Okay then. All right. Thank you very much, everyone. Bye.